The Story of Everything, Chapter 6, The First Second, the Hadron Epoch. Welcome to a new era, the early universe, Sophia declared, and we now enter a new epoch, the Hadron Epoch, which lasted a whole second. Thanks be to God, I said. During this first second of the universe's history, which lasted 1,000,000 times longer than the entire very early universe era, the orb of the observable universe grew from many times larger than the solar system in diameter to nearly 20 light years in diameter. And how big is 20 light years, I asked. She said, if you made an orb around the Earth 20 light years in diameter, it would only contain the 9 nearest star systems. That means there would only be a few stars in the night sky. That's a big orb. It takes almost 4.5 years to get to the nearest star system, Alpha Centauri, traveling at light speed. But when you consider that there are about 400 billion stars in the Milky Way, it's so tiny that if you had the whole Milky Way in view, you wouldn't be able to see an orb of that size. Got it. Still, that's a huge increase in size, and so, as I'm sure you can guess. I said, the temperature and density dropped? That's right. The temperature dropped from 10 trillion degrees to about 5 billion degrees, which is still hundreds of times hotter than the center of the sun. And the density will very rapidly drop from something like a neutron star to something like lead or diamonds. Now, let me take you a little way into the very beginning of this first second, about 15 microseconds in, when the most important event happened. And now, Mother, I will continue Sophia's story in my own words. Chava, the elevation of matter seems to begin with the Hadron Epoch, because it is here that something truly came into act for the first time out of the potency of the fields. For the first time since the Big Bang, a new substance came into being. That's significant in itself, but I suspect it's even more significant in the larger context that God likes to start from small things, from next to nothing. Being itself called forth being out of nothing. Perfection called imperfection to a journey toward perfection. Sophia says this is one of the things the angels didn't understand at first. Because they are perfect beings, they didn't understand this alternate material storyline. Of course, they didn't realize yet that they too had a story that was only just beginning. But to start from the pure imperfection of prime matter was an impenetrable puzzle to them. Nevertheless, they were fascinated by this evolutionary process, that such a beautiful, lush, blooming tree of the universe could come from such a simple, tiny, formless, and void seed. What was new to them during this epoch was that the notion of composition came into play. They had seen the division of forms into the 30 or so fields. Now they and we were about to witness those forms combine for the first time in history to make something truly new. This new thing existed in potency in the individual fields, but it was now going to exist in actuality, which is true and proper existence. And equally remarkable is that this is something the universe did all by itself, having received the natural laws governing the fields and their interactions from their creator, who is himself interaction or relation. Personally, I found the universe at the beginning of the Hadron Epoch to be a hot mess, literally. There were way too many particle wave ingredients doing seemingly nothing constructive except bash into one another. So I was glad that composition was finally coming into the picture to help clean things up and simplify things. Actually, composition means greater complexity and new forms, but I mean, as far as the particle soup goes, which is not fit for human consumption, I was ready to see the ingredients get either mixed and baked or put away rather than just lying on the kitchen counter. And this was about to happen. From now on, the story of the universe will be one of simplicity due to fewer particles on the one hand, and, on the other hand, synthesis, construction, and increased complexity of forms. Composition rather than division. Between about 10 and 20 microseconds into the Hadron epoch, two major things happened. First, due to the expansion of the universe and the subsequent stretching of photon wavelengths, the energy of the thermal bath of the Big Bang fell below the energy at which photons could smash together to generate the heavier, more exotic particles. This means that the gazillion blizzard of bizarre particles that filled the universe at this time, like those second and third generation heavy particles we talked about earlier, which can only be found in extreme conditions, like near black holes or in particle colliders, those either found their antiparticles and annihilated back into photons, or they decayed into lower energy normal particles, like electrons and up and down quarks, the stuff atoms are made of. Hence, the content of the universe rapidly simplified from several dozen types of particles, all in equal overabundance, to just up and down quarks and antiquarks, electrons and positrons, the positron being the antiparticle of the electron, the neutrinos and antineutrinos, and photons, gluons, the W and Z bosons, the Higgs boson, dark matter, dark energy, and whatever gravity is. It was like nature was measuring out the ingredients she was going to use and putting the rest away. And by putting away, I mean turning them into the handful of particles just mentioned through decay, or turning them into the pure energy of light by annihilating them with their antiparticles. While this simplification was happening, the complexification of constructing new forms out of simpler forms began. Quarks and gluons are very friendly and obsessively loyal, but at this point they couldn't form associations yet. Remember, the bungee-like gluons can only bind quarks together if the quarks are far enough from each other. The up and down quarks are charged. Positive charge for up quarks and negative charge for down quarks. The like charges repel, which gives the gluons the tension they need to go to work. But the universe was so dense in the previous epoch that the quarks couldn't move far enough away. With the universe now being dozens of times bigger than the solar system, and the cleanup of unnecessary particles underway, the quarks finally had enough room to breathe and could move away from each other at a comfortable distance. When this happened, the gluons for the first time exercised their full gluing potential, and hence the first structures in the history of the universe were born, hadrons. A hadron is a binding together of two or more quarks by gluons. There are many exotic and weird hadrons, but only two are stable, and only these two would survive the Hadron epoch: protons and neutrons. Protons and neutrons are called baryons. A baryon is a hadron made of three quarks. Protons are called pro because they have a charge of +1. This is because they are made of two up quarks, which, if you'll remember, each have a charge of +2/3, and one down quark, which has a charge of -1/3, for a total of plus 3/3, or plus 1. The neutron is called the neutron because it has a neutral charge of 0. This is because it is made of 2 down quarks and 1 up quark for a total of 0/3, or just 0. The other hadrons, like mesons, which are made of pairs of quarks and antiquarks, quickly annihilated away or decayed into the 2 kinds of trinity-like baryons I just mentioned. With the arrival of hadrons, the most important being the baryons, the universe for the first time contained true bodies, namely these so-called atoms of matter called protons and neutrons, along with an equal number of antiprotons and antineutrons. No longer just waves rippling in a field, these atoms were solid structures, true particles, true substances with a size, made from the fields, but at the same time something more than just the fields. They were true material bodies with their own unique existence. Material reality was now the fields and these new baryons. Our own bodies, Mother, are made from just electrons and these very baryons I was seeing all around me. It's wonderful to think that our visible bodies are drifting along these invisible quark gluon and electron fields. All material things are connected by these fields because we are all manifestations of these invisible fields. Of these 4 baryons, the proton, the antiproton, the neutron, and the antineutron, the first 2 can also be called hydrogen and antihydrogen. I should explain. Elements like gold and oxygen are clumps of baryons. These clumps, if they have electrons orbiting them, are called the nucleus of the atom, with the electrons forming the shell. That's all atoms are, a nucleus of protons and neutrons, and if the environment is cooler than a star, a shell of electrons. Hydrogen is the simplest element, consisting of a single proton and, again, if conditions are cool enough, a single electron orbiting it. The antiproton is simply antihydrogen. The neutron is basically an unstable, slightly heavier proton that naturally decays into a proton. So you could think of neutrons as soon-to-be hydrogen. Now here's an astonishing thing to consider. Because the baryons and antibaryons and the quarks they're made of had only just recently stopped being formed by photon collisions, because there was no longer enough energy to create baryons from photons, there were still as many baryons as photons, because remember, the energy to matter and matter to energy conversion had been equally probable until now. But there are a lot of photons in the 21st century, way, way more than there are baryons. In fact, at a ratio of more than 1 billion photons for every 1 baryon. This means there were a few billion times as many baryons in the Hadron epoch than there are in the universe today. That's a lot of matter. So what happened to them all? Remember, there were an equal number of antibaryons. So what happened to them all is that by about 25 microseconds, they all annihilated away into photons. But then why do we have any baryons at all today, which is the stuff everything in the universe is made of? If there are no baryons, there is no stuff, just empty fields rippling with waves. The universe would be completely dark, empty, and cold today. The answer is the most astonishing asymmetry since the uneven exit from inflation. Asymmetry is a word Sophia taught me, Mother. I had no idea what it meant. As a reminder, symmetry is a kind of mirror-like balance, or an even distribution of quantity or quality over two sides. If you split a human down the middle, the two sides are reflections of each other. That's symmetry. The fact that we have 5 fingers on one side and 5 on the other is symmetry. That a seraph has 3 wings on one side and 3 on the other that look the same and are in the same position is symmetry. Snowflakes are symmetrical. They have a 6-fold symmetry in that they have 6 spokes evenly radiating outward. If you could fold a snowflake in half, the 3 spokes on each side would line up. That's symmetry. Sophia says, as I write this on top of my mountain, that the angels are perfect symmetries. That's why they didn't understand what seemed like yet another seemingly ugly imperfection in the universe. The second ugly imperfection after that random lumpiness of the density of the universe. And that is the asymmetry I'm speaking of, the breaking of symmetry. You see, the baryons and antibaryons did all annihilate, but because of a tiny imbalance planted in the very early universe. When every 10 billion protons annihilated with every 10 billion antiprotons, as it turns out, there were 2 or 3 protons left over. The same happened with the neutrons. This means that the very early universe, for some reason, produced just a few extra baryons for every 10 billion antibaryons. The modern day universe contains about 10 to the 80 baryons. So that means there were about 10 to the 90 baryons during the Hadron Epoch, an inconceivably huge number. Now, you might think that 80 versus 90 doesn't seem like a big gap, but remember, these are powers of 10. The number 10 to the 90 is in fact 10 billion times larger than 10 to the 80. The reason for this tiny imbalance will have to be saved for a more in-depth discussion of particle physics some other day. For now, you just need to know that by the end of the first second of the universe's history, all the antimatter in the universe had annihilated away, leaving only the tiny, if you can consider 10 to the 80 tiny, residue of protons and neutrons. The universe could now go to work combining these surviving protons and neutrons into something more complex than just hydrogen, stuff like people in skyscrapers. Why do we need protons and neutrons to do this? Can't the stuff of the universe be built out of just one or the other? The answer is no. It's extremely difficult to combine 2 protons because protons repel each other. Remember that like charges repel. And it's flat out impossible to build any element heavier than hydrogen out of just protons. To add 2 or more protons together to assemble new elements, you need 1 or more neutrons to stabilize the nucleus so that the like-charged protons won't repel each other. An element, by the way, is defined solely by the number of protons. Hydrogen has 1 proton, helium 2, lithium 3, and so on. So again, if you want something more than hydrogen, you have to have neutrons. But there was a major problem at the end of the first second of history. As Sophia put it as we stood there in the bright fog of hydrogen and neutrons, neutrons floating by themselves in space are unstable. They have a half-life of 10 minutes and 10 seconds, which means that 10 minutes from now, half of them will be gone, decayed to protons, and after 20 minutes, they'll all be converted to protons, leaving the universe as nothing but a collection of hydrogen clouds for all eternity. Something major has to happen, and happen quick, to save the neutrons so that they can join with protons to make something other than hydrogen. because you can't make anything out of hydrogen and hydrogen except more hydrogen. In 1/6000th of a finger snap, too quick for human perception, the universe had grown from nothing to dozens of times larger than the solar system, and of course, the unobservable universe was much bigger, and new substances had come into being, protons and neutrons. By the end of the first second, things had calmed down. With all the exotic particles having annihilated away or decayed, the ingredients of this dense, blindingly bright, foggy universe were now much simpler. There were the baryons we call protons and neutrons, which gathered up all the loose quarks and weak and strong force particles. And there were 10 billion photons, electrons, positrons, neutrinos, and antineutrinos for every 2 or 3 of these baryons. And there was the Higgs boson to give matter mass. And there was gravity, dark matter, and dark energy, whatever those are. But the only actual substances with solid structure, as opposed to invisible fields or mere ripples in fields, were the 10 to the 80 protons and neutrons. Somehow those protons and neutrons would turn into people and books, but only if the neutrons could survive.